Thank you. Well, welcome everyone to our BCS Animation and Games presentation today, and the AGM will follow shortly after, but we've got the really interesting bit beforehand in a presentation called From Scan to Story. As you can see there, teaching games programming through 3D capture and immersive technologies. And we have Verda, Matthew and Zander on, who are going to present this to us. And thank you very much for rescheduling after we had a slight Zoom upset last time round. Apologies to you and to anyone else that was was trying to get in. When you lose Zoom completely. So I would like to hand over. I'll let you do the introduction, and I'm really looking forward to this one. So away with the show.
Thank you very much, Ian, and thank you, Margaret, as well. My name's Matt. I'm based at the University of Glasgow. I'm not the main attraction today by any means. I'm just here to introduce, really, my two colleagues who are going to be talking today. One is Verda Munir, who is a lecturer in games development and a researcher at Robert Gordon University up in Aberdeen. And we're joined also by Zander Purvis, who is a foundation lecturer in computing at Abertay University. Both have been very much involved in the education side of things and in computing science, and are very enthusiastic and caring educators. So I'm very keen to hear what they have to say about teaching games programming. So I think what we'll do is these guys are going to speak for maybe 45 minutes, something like that. If you have any questions, please put them in the chat, and I will put those to the speakers at the end. But over to you, Verda and Zander. Thank you.
Thank you all for joining us today. I wanted to welcome everybody. We are going to dive into the fascinating world of games and teaching games through the use of 3D capture and immersive technology. As you know, thank you for the introductions. I'm Verda. I'm one of the lecturers at the School of Computing, Engineering and Technology at Robert Gordon Uni. I teach games. I have a background in games in terms of research. And over to you, Zander.
Hi, I'm Zander, Foundation Lecturer at Abertay, and my current research is around how games can be utilized to not only educate, but also potentially deter cybercrime. So to give you a brief overview of what we're going to talk about today, we're going to talk about how we met through the Sixth Scholarship. We're going to introduce you to the concept of cognitive load and why this has inspired us to think about the pedagogy of tackling it. And then we're going to break down our process and introduce you to the scan story pipeline, which I think effectively encompasses this kind of process and pedagogy. We'll take you through some student projects that resulted as from following this pipeline, and then have a look at how industry approaches and research utilizes this type of technology.
So let's talk a bit about the SIXA Learning and Teaching Scholarship. So those of you who don't know this, it's a professional development initiative aimed at ECRs to mid-careers for computing and related subjects at SIXA members institute across Scotland. We had a mix of networking opportunities, mentors, and workshops, and that's where we met kind of Matt, and he kind of guided us and mentored us through the process and developing this scholarship. Me and Zander grouped and explored the common theme we both were interested in, which was how do we kind of make something that we like, games, and how do we make this learning more approachable for everybody? It is about a concept of creating an environment where learning through games feels natural and engaging. And we want to avoid the daunting part of it. We want to reduce barriers and we want to foster curiosity. By making games approachable, we open possibilities for deeper understanding and creativity in educational setting. It's about inclusivity and accessibility for all kind of learners, and that's what we wanted to explore further and how we could make it better.
So what is cognitive load? Well, it was coined by Jonathan Speller, and the basic premise is that working memory only can hold a limited amount of information at a given time. And thus, when you're trying to teach something to someone for the very first time, you want to minimize how much information you're giving them all at once so that they have a better chance at succeeding in their first kind of tasks and let them explore their learning, and that they do not get overwhelmed, which can shut down learning and force a student to tune out. So if we have a look at how this relates to games, this is the opening screen when you open up Unity's game engine for the first time. So you can imagine if you're sat down at your first kind of games lecture and you're told that you're going to be using the tool, you open up the tool. No matter how much detail is in the lab sheet that you've been given, it's an intimidating thing to open this up and try to work out what all the windows are doing, all the menus are, all the possibilities, and you're probably a bit shy about potentially breaking something as well. So there is this hesitancy before you can engage and start to learn the tool that is encouraged from just the amount of information that's presented to the user. And if we look at Unreal, another game engine, this is time with a project. This is the base kind of first-person template that you can open up. It doesn't help matters. It actually kind of makes things worse. There's even more going on in the scene now, which again can shut you out of the learning experience rather than let you step on a small step, achieve some success, and build your learning up slowly.
So when we were talking about all of the cognitive load, some of the things that we like about teaching, we also wanted to get a more published version of what would help and what wouldn't. And then that's where we considered some of the pedagogy frameworks within education and learning. So we wanted to look about creating learning experiences that are active, inclusive, and meaningful. The focus was that we wanted to help the students build knowledge through reflecting, collaborating, rather than just, consuming the information that we were giving them. On the flip side, we wanted to avoid practices which would, for instance, put the technology first ahead of learning and kind of assume some kind of prior experience in learning from students, because students come from different stages. Some are continuing students. They might have some background in, for instance, programming. Others might not at all. They might come from a very arts background. So instead, we wanted to keep things flexible, supportive, and importantly, culturally aware. So student feels empowered and to take the risks and grow. To be honest, it's literally striking the right balance, giving enough structure, but also leaving space for creativity and agency.
So why does this matter? Well, again, if we're trying to decrease cognitive load, we want to encourage a nice accommodating space for students to learn. First of all, that's a good way to decrease it. So making the process less intimidating. By taking a narrative first approach, this can eliminate some of that intimidation. So if you, instead of telling the student that you're going to be tackling a subject and you're going to have this kind of outcome, you can tell the students that are learning games for the first time that they can come up with a narrative, that they can decide what is it that they want to tell the user or the player, and then they can begin to turn that into a plan. So it's their plan, they have ownership of it, and that informs them of what tools and mechanics that they will need to learn in order to actualize that. You can introduce the idea of visual coding to reduce cognitive load as well, so you don't have to learn the language. You can focus on, okay, what is it that can make the mechanic happen. Collaborative prototyping is something that's good again. So it's this idea that you can come in as a group rather than tackle something alone, so that people can share things, although this can present challenges too. But the main thing that we try to zero in on is playful experimentation. So getting things wrong shouldn't be a barrier to progress. It should be part of progress. So it is about this. I'm going to attempt to do things. I'll see if it works. If it doesn't, I've learned a lesson as well.
So what I want to do is maybe break down a bit of the learning process, what that means for the students. So creating a healthy environment in video games is especially important because it kind of directly impacts the students' load receptivity and how they're going to engage with the content that you're delivering. And of course, we want to have sustainable practices, right? We don't want students to just shut down when they see something. We want to encourage enough curiosity that they keep coming back, to learning more and working more. I'm going to talk a bit about the must-haves of a learning environment. So we initially thought that the first thing of any learning is the environment where the student feels their voices matter. We wanted to empower students so that they could actively engage and share their expertise and unique experiences. Um, to be honest, we've all made mistakes. Uh, what we want to realize here is mistakes are not failure. There are opportunities for growth, and embracing this mindset, we kind of create a safe environment where students feel comfortable taking risks, and reiterating some of the things that they have done. A touch of humor and a casual tone goes a long way. It eases tension and make learning more enjoyable. I'll show you a quite fun example of this later on. Our goal is to inspire enthusiasm. Uh, it is contagious when we show passion to our students. They feel passionate about the subject, they feel encouraged, and they feel more curious and enthusiastic.
So, as a first kind of experimentation in actualizing some of the pedagogy that we've identified as good practice when trying to learn how to do things for the first time, I launched a collaborative coding lab. So the idea was that we would come together. I had 100 students and there was one programmer, myself. So we had a task that we would try to program collaboratively. So the idea is that the students would vote at the beginning of the week on what task we would try to achieve. I think the game Bellatra was very popular, so they liked to develop small casino-style games, which was an interesting topic, but led very well to 1 to 2 hour sessions where we could actualize these. So I would be in the kind of pilot seat where I would be typing things in. The students would be sending messages in as to suggestions of what I should program next to achieve the next step in our system that we were building together. This was team taught, so I was able to concentrate on the programming where a colleague of mine would be keeping an eye on the chat, and they would be interacting with the students and bringing forward the most reasonable or interesting suggestion to program, so I could concentrate on that. This had absolutely great engagement. Lots of students found the lab fantastic, had very good reflection in the module feedback. But this also helped normalize mistakes. So as you can imagine, if you're sitting typing in front of 100 people, you're going to make mistakes if you're doing this live. So this really helped encourage the students that mistakes happen. It strengthens debugging skills, and it's not a problem if you make a mistake. It's actually an opportunity to learn to a deeper level what it is that you're trying to achieve. And yeah, that was very well attended. So we further thought about, okay, well, it's great to have a fun, engaging classroom. It's great to have participation, but we were thinking, how can we give the students more ownership? So, like I said before, we had them suggesting and voting on a topic that they wanted to engage in. But if they are trying to learn something for the very first time, one way to really motivate them is to come up with something that they want to share. So having this narrative first approach not only defines what it is that you're making, the end goal, and gives you an idea of the tools that you need to learn to achieve it, but is also motivation. If you want to share something, you're going to work to make that happen.
So now we've established some of the things that we want to create a safe space. We want to give students the choice. But what do we do with all of these choices? Now we dive into the world of interactive design. It is based on shared stories, rituals, and places. These kind of elements bond between the participants, making them experience their experience more personal and memorable. We kind of explore the immersive world that foster emotional engagement, kind of transforming the passive learning into active participation is kind of the goal, and making technical concepts more relatable. And again, it's just not about those narratives. These kind of practices, they are a bridge to technical learning. But by embedding some kind of storytelling into the design process, we wanted to make the complex information that we share with our students easy to digest and apply. As we move forward, we want to think about how these kind of elements have those personalization, narrative stories, and some things that we're passionate about have an impact on our own projects.
So with the idea of trying to communicate something to your user or your player at the end of your project, this also got us thinking about art as a way to get emotionally invested in what it is that you're building. And when we were thinking about this, I couldn't help but think back to my third year project where I was particularly getting invested with my work. So this was a small project to learn about how to implement sounds within games. So we were creating our own kind of Foley sounds and things. But alongside that, I found that I wanted to create an interesting world to kind of experience these sounds in, things that felt like an interesting environment to be in and explore so you could listen to the sounds. So this was a game about a girl who traveled through different dimensions to capture some sounds for an objective. But as I was putting this world together, I really wanted it to look good as well as sound good. So much so that I even tried to find like a cassette for my kind of UI element. I could not find a suitable cassette asset, and I don't have any art skills as a programmer mainly. So I made this thing in PowerPoint with like a bunch of shapes that I think came together quite well. But it's this, you know, although I was doing like a slight side detour around the project, I got really interested and invested in the project, which gave me basically the space and capacity to do more work, which pushed me to work even harder on the main objective and make an interesting project.
So this kind of brings into some of the things that are also common between me and Xander, having no artistic skills whatsoever, just because I have been associated with the technical skills so long. The only art school that I joined was DGCAD, University of Dundee, for my master's. And even in there, I just was exposed to scanning and whatnot, and which I'll come to later on and explain how that helped me get through this. So there are some of the problems, for instance, some limitations that you can't resource all the free assets. It's time taking. You need to find kind of assets that match your narrative. They might look drastically different with different styles and aesthetics, which kind of results into that you don't really have control over the art direction, and which might not be something very encouraging for students at this stage, because when they start looking at resources and things that they don't find, and they quickly are like, no, we don't have a good starting point, like what are we going to make? And basically your game will have the majority of the assets you have. So and it's a lot to do with copyrights as well. So some of the things that the students may or some of the resources that they find on the internet are not free to resource, and they have copyright issues. So some of the things around this kind of makes it harder for the students to blend their, assets into the 3D world. There are other things, for instance, if you can't source some of these assets, well, potentially you could create your own assets if you have 3D skills or art skills. It does take a lot of time for creating your own assets, which means that it massively distracts the students from the time that is available to study and learning material for creating your own assets and knowledge, not only in art, but also in the implementation process to get that art embedded into that narrative and mechanics. So this is where the scan to interactive story pipeline comes in place. We kind of blended together some of our own experiences that we found during our own projects, some of the things that we faced with students, some of the things that students reacted well to, and some of the things students shut down on. So we kind of blended it all together and did some things with the pipeline. So this is the research framework that I worked during my PhD research initially, which investigated the need for developing a solution that would kind of democratize the access of using these, for instance, scanning techniques and creating AR archives for the 3D reconstructed model. The workflow initially was meant to eliminate the digital divide. For instance, the scanners that I was exposed to in my master's were very costly and were resourced through funded projects for the university. But when I think of back home, for instance, in Pakistan, like there are a lot of things that I could scan, but I wouldn't, or the faculty there or people wouldn't have the resources to get those heavy invested scanners. So there came my inspiration for creating a solution or a prototype that would kind of give accessibility to everybody that is wanting to bring something into a real world, right? Bring those objects into a real world. It utilized cost-effective things and solutions with immersive visualizations. It was applicable for stakeholders who had tech experience and non-tech specialists as well, regardless of their experience in the 3D. It was crucial that they took everybody who wanted to bring something into a 3D world or preserve something in 3D. For instance, suppose you were not able to take a picture of your own culture or of your own family, of an event, right? And if only certain people had, for instance, the cameras that, that could do it. But you want to take narrative in your own hand, right? You want to tell your own cultural story and background. And this is why it's very, I think, important to me that we have that. So the research framework leans towards photogrammetry. I'll talk a bit about what photogrammetry is and reconstruction to create 3D models. Then that went into the second amplify imposter, which is basically when you create, either use 3D scanning techniques like LiDAR scanning or photogrammetry techniques, the resultant model, 3D model or mesh that you get is very high topology. And in order to be used for games or any virtual simulations, we need to reduce that topology. And last bit is the providing an AR tool that would allow, for instance, to blend in the 3D and the real world and create that visual experience. In order to validate and scale this framework, it was tested through 3 case studies for the archiving. The heart in the center you see is an actual human heart. So this was done through training staff at Aga Khan University back home, where they have this real human specimens. I didn't want it to go very explicit in terms of the imagery I was going to show here, but I do have a scanned half human cut head that I trained the staff back home. But what that meant, because it was even during COVID times and students didn't have access to the labs, they were able to use, for instance, the 3D model to just have a look and view of the actual things that they were meant to be seeing through that specimen. Another on the bottom left is the one of the Chinese cultural artifacts that you can see in the Chinese temples. I was working with students that were based in China at the time, and just because they were in the city with such rich culture and history, that they had access to those artifacts and those statues, those monuments, they were able to scan those and bring them to a gaming world, which was, I think, an amazing thing to test out, not just for education, but cultural preservation as well, and for games. The third bit on the top that you see a wee bit of a castle type structure. It's a school in Jones Haven, which is Latalan. it's a castle turned school, so it's got that rich culture aspect to it. So I wanted to use this kind of as a base for historic preservation, some of the things that we could show as Scottish culture within games. So some of these things kind of really blended it with some of the things that we were finding. So why not just use, for instance, I was using this for education and healthcare, right? Or in medicine, but we combined with some of the things that we found out during, working together through the scholarship, and we kind of merged kind of these elements together. I'm going to talk a bit about photogrammetry, and I'm going to show you kind of what that means so you understand what that is. So photogrammetry is just a technique of taking a lot of overlapping pictures of any objects, structure, humans, and once you have a lot of pictures from different angles, different distances, you can then just give that to a software. It will create a 3D model in a resultant. Just to show you, this is me taking lots and lots of overlapping pictures of a stone. And you can see on the bottom left is the image trail that I'm having. So it kind of goes from taking pictures from distance to close-up pictures to really close shots and different angles as well. So some of the things that some photos I've taken might be from the top, from the bottom, from the middle, and on different angles. And you can see the resultant mesh that we have in 3D is a very good demonstration of, the model that was just created from few photographs. The cool thing about photogrammetry is that it doesn't require expensive hardware or software. There are free to use resources that you could use for creating that into a mesh. I kind of literally used iPhone 6, which I think, to be honest, it was decade old that time. And that kind of created really good assets. So I kind of encourage my students that this kind of things shouldn't limit you. These kind of things should empower you. Investing in technologies that kind of give you, empowerment over the workflows. So how did this kind of reduce the barriers or reduce the cognitive load? Because it's entry into the first step, right? They're not required to create those 3D models or worry too much about what kind of assets go with their narrative or with their project aesthetics. Rather, like they have kind of fun experimenting with this kind of objects, uh, because they kind of bring those. So the first literally task is the students bring objects that you like. I am going to admit it's a bit enthusiastic because when one of my students once brought a skull, I was too afraid to touch it, but I did scan it. They might have some this. So we from objects to humans, we get different other lecturers to model for us for getting them scanned and bringing them in the game engine. So it's quite fun. Because when students are experimenting, they're still practicing the technique of photogrammetry. You might have some disconfigured human models, which is absolutely fine. Some like to use it as it is and make it part of the game. That's absolutely fine. But this kind of easy completion can make the students more invested, I would say, into the game. And as they complete the first act with ease and fun, so we have kind of encouraged them to look further and to be curious enough to go into the next steps.
So one of those next steps is getting it in your game engine, and once you've just dragged and dropped the file in there, which is easy enough to do, there is some rigging and animation to do. So if you think back to that big screen that hits the user at the beginning, we're kind of preparing them for that by saying, you don't have to learn everything. You don't even have to do any programming at this step. You can just do the rigging of the model. And this is one particular window in the set. So they're told at the start, you don't need to know all the other things. We're just wanting you to look at this one particular element for now. Unity in particular makes rigging very easy. So you can see that there is the kind of shape. And the idea is that we are basically implementing this kind of bone structure in order for the animation to affect the model. So some of this can be set up by the student, but there's also a way to kind of have this done automatically as well. So one of the traditional ways of getting animation and models into the game is a website called Mixamo. Lots of students just find this on their own and they go for the animations and models in here just because it's free and they have quite a lot of choice. So like I said, you know, it can come with its own models, like this little goat guy here, but you don't have to use those. You can just use the animations. So once you place an animation on a model that's perhaps your own, it'll begin to set up, you know, options for what kind of thing this is being animated is. So you can select humanoid, and that'll give you kind of your basic humanoid bone structure, which you can tweak if it doesn't quite fit your model. But yeah. So how does this reduce the cognitive load? Well, it's a targeted approach. You are just asked to look at the animation rigging section of Unity. This can encourage you to just ignore and start blocking out stuff that you're not sure of. You're just focused on this one task. You're already kind of invested to do it because you created your scans of your object, so that's something meaningful to you. And it's also an interesting payoff. So one of the first things you're doing when trying to learn a game engine is you might make like a square, and then you might rig that square up to be able to respond to some keyboard movement. So you can move the square around the screen. For some students, this works out at a really good investment point where they actually see something reacting on their screen that they made happen. However, the problem with this is that you first have to create your square. So you jump into the assets, you go and work out how to create that in your game engine. You then have to learn how to attach your coding editor, like the Visual Studios or something, to Unity. So you're working with two tools instead of just one. You're then programming within that and then attaching that script that you've just programmed to your object to finally make your square move about. Whereas following this method, we've implemented our object, which we care about. It's personal to you. It's not just a random square. And you're able to have that play an animation that you've chosen, making it very visually impactful and rewarding to the student for less effort than they would normally be implementing.
So I'm going to talk a bit about the implementation now. The first was scanning or getting those assets scanned. The second was getting some animation and rigging, as Anders said. The third bit was, so I've scanned, so there's one of our lecturers in the School of Computing, Ross. He kindly agreed to get himself scanned. We brought his character into 3D Blender. We did some touch-ups with the color. You know, if there were some gaps and holes, we would fill those gaps. And you can see it's quite a good model at this stage. We also implemented some of the dance moves for Ross just to see, you know, our character was, you know, blending in well with the animations. So see these kind of touch of humorous things and just having, for instance, a lecturer agree to be a part of their model. And on student request, we did put his character on fire, which he was totally okay with, I think. But what that means is what that tells us, like you could bring objects to real life. You could not just have them static. You could add animations to them. You could make navigations and interactions within your game through that. So now we've entered him into that 3D game that we created, and we added particle effects. We added different navigations, colliders, collisions, triggers, and all these mechanics that, you know, the students are now really, really invested. Now they see the character being set on fire. They see all these interactions, and now they want to do so many cool things within their own games. So how does this kind of reduce the cognitive load? As I said, scans are done, assets are animated, we've added basic integrations. The students are, as a result, students are having fun. They know that they need to understand, they don't need to understand everything. And the next step is how can they find now, at this stage, literally, if I take this and compare it to any other Unity modules, this is not very different. The only thing that we are adding is an element of personalization and adding elements, giving students a choice to really include things that they like, or they they have, or they possess, or something that's a memory to them, and we bring all of this together. And yeah.
So now we're going to take you through some student projects that were created as a result of following the pipeline that we've outlined.
So in this project where the pups, this is actually a playground in Aberdeen. This pink house is in RGU. Nobody knows why this miniature exists at RGU, but it exists. It's a miniature house. The student actually went on to scan the playground in Dirty Park. As you can see, this is a kind of a replica of the Dirty Park playground area for children. They kind of had these little cute miniatures that they also scanned and bring that into a gaming engine. So it was a quite fun experience to play as a game and even to watch. This is another example of the Snoopy Diner, where the students kind of scanned the character, brought those scanned characters or scanned objects into the gaming environment in form of a diner. The Snoopy, being the owner of the diner, had to, for instance, boil the kettle, and you can see different particle effects, triggers happening as well when the player interacts with those objects. So this is kind of very fun way to bringing those game elements without having the stress of bringing those mechanics within a game environment.
This Keep the Kitchen game made by a student follows like a very heavy dynamic attached to the objects that they've chosen to scan. So the student wanted to scan their whole kitchen, which is no small feat. So the room itself, along with all of its bits and pieces, meant a lot to them. And the idea of being shrunk down and having this fight escalate in the kitchen was meaningful to them. That's something they wanted to communicate to the user. So much and so that they faced some challenges which they were trying to overcome. We'll see those in a moment. I think we also see some of the human deformation that Berger pointed out, which they've incorporated into the aesthetic of the game. So this was a character they've made out of food, which is part of the game. Oh, and the challenge, how I said, so this knife would not scan very well inside of their game. So they actually broke it into two pieces, scanned them separately, and then reattached them inside of the game as an object. And like I said, into the narrative, the food guy is your kind of guide to this world as you find it and you're shrunk down, but then turns out to have been betraying you this whole time, in which case you fight him. And then we see a student that's taken a very opposite approach, which is really interesting. So this one involved them scanning their Spider-Man toy, and they've really zeroed in on the character. They've done little in terms of like building the world around the character. They've got a few little houses and things like that, but they've gone really all in on making Spider-Man have basically all of his abilities and making those work inside of the game. We see the ball running, we see the web slinging, and we just see how much work they've put into making the animation style fluid, like you would see in the movies and comics and that you associate with Spider-Man, and combine it with this kind of cheeky attitudes that he's given the character here as well.
So now we want to talk about student results, the kind of results that matter. I teach most of the Unity modules in the department, but students have said this to be one of their favorite modules because they get so much fun in bringing these things to life. And there have been recorded minimum to none non-submissions for this class, and the average grade tends to be a B. I always say to my students that it's about having fun while making games, but it kind of resonates particularly well within this module. This framework is designed to make learning fun, right? To give students agency and truly empower them. Fun comes from the creative freedom we give the students to choose their stories, their themes, their objects, humans, and making that personalized for them. From the very first task, students are taking action, shaping their own learning journey, and they're making decisions that kind of matter. And empowerment, that's kind of the result of the research-led approach that we have taken for this. And by experiment with game mechanics and flow, students learn to iterate, fail, and try again. They gain confidence not just as creators, they also see tangible outcomes from literally navigating from the first task to the last.
An additional interesting aspect to engaging with photometry is that it is an industry-used tool. So we'll take a look at one in particular project here. So Moonhood is a company behind the Midnight Walk. Their stated goal is to immerse players in strange handcrafted worlds that they utilize from or build in actual clay, cardboard, and anything they can kind of lay their hands on. And you can see that this gives the world a very interesting, real aesthetic. And yes, the really cool part for the students when you tell them about this and show them is that they are engaging with exactly the same technology in exactly the same kind of pipeline that they're learning to practice. So it invests them in learning again that this is an industry standard thing, that you can do it to a very high standard and create something really polished and interesting with the tools. And you can see that when they implement these assets inside of their game, it's pretty much the same thing that the students are doing, just done to this really highly polished professional level.
So we have talked about making games accessible, making games fun, taking the stress out of for students. We've talked about scanning things. We've talked about what helps students. We have also looked at that the kind of things that we are wanting to do. It's very much industry focused, as Sander said, but there are some other things, some other aspects to scanning that could be further explored. And we are also working on some of those things, which include, for instance, the cultural heritage side of things, which means digitally preserving and exploring historical sites and artifacts and environments in serious games. Players engage with culturally significant narratives. We can also, for instance, engage the community for these narratives and heritage conservation projects. The other thing that we could do is create simulated environments. For instance, like due to the climate change, we could kind of have a deforestation or a climate impact simulation. These have been very useful for, as I said, medicine, but have got a big scope in terms of healthcare and therapy. You could scan rooms and objects for patients to help them navigate familiar or therapeutic spaces. This is not an exhaustive list whatsoever, but also looking at some of the training that we could do around simulating fire, flood, or evacuation scenarios could be very useful using the technologies within this. Uh, Now we're going to kind of wrap up with some key takeaways. Our approach kept learners at the heart of everything we do, ensuring inclusivity and active engagement. That kind of aligned with SDG 4, quality education. We're not just teaching theory, we are integrating cutting edge research and current trends. So students graduate for real world challenges that are kind of encompassed by SDG 9 by driving innovation through research and strengthening the link between industry and academia. These are examples of applied research that kind of connect technology with cultural heritage and sustainability, supporting the SDG and UN SDG and 11 by preserving history and creative immersive experience. I hope by now that you have kind of enjoyed our talk, and thank you so much for listening to us. And now we are open to any questions that you may have.
Brilliant. Thank you very much, and lovely slides. I mean, you're saying that programmers can't do art, but come on, this is this is excellent. Okay, thank you very much. We've got a couple of questions in the chat, and I have a couple of my own. If anyone else has any questions that come to mind, please do drop them in the chat. But so Margaret is asking, first of all, saying thank you for an interesting presentation. But before they take this module or the modules where you use this approach, how much experience have the students had with playing games and also with programming? I imagine quite a bit of the former.
I think between programming, it's a mix because some of the students come from an arts college background and they've not done programming before. So sometimes it's a blend. Sometimes you get students who studied programming, for instance, in the first year, and considering this is a blend of second year or third year direct entrance, some might have some relevancy with those skills.
Mm-hmm. Okay. And what about game design? Have they been exposed to game design by this stage?
Even if they're not programmers or whatnot, they have played many games, most of our students. An example was, I think, just last weekend when we were doing the game jam, we wanting to spend some time with the students just to, till the time judges announce it. So we did kind of a quick pub quiz kind of things for games. And the students didn't even let us finish the question. The amount of the knowledge they have playing games and how
Right.
they kind of bring the things that they like about those games into making games.
Okay, great. Thank you. We have another question here also from Ian saying, have you started to roll in the generative AI 3D tools?
We use Polycam. We've got a license for it. There is in Polycam, I think with the recent update, they've got scan to 3D model as well. I have given it a go. It's good as well. Because we're talking about reconstruction pipelines, right? It does not limit them to either LiDAR scanning but yeah, we are quite open to using AI in terms of just quick prototyping and getting students just do some quick mechanics and whatnot.
Yeah, okay, great. I was curious about the modules learning outcomes. What are they expected to take away from this, and how do you assess that, just from a professional point of view?
Xander, do you want to go or should I?
Yeah, I think
Sorry, I feel like I've been speaking.
learning outcomes. Yeah, no, feel free. You did a great job.
Yeah, so I think some of the learning outcomes were around reconstruction. So telling them that it's okay, doesn't matter what kind of mechanics you have in your game, as long as you get the techniques of scanning right and creating those prototypes. They're not meant to be polished in any way. So these kind of learning outcomes help them. There are certain outcomes directly relating to creating levels, designing those levels, but they kind of blend in naturally with some of the things that they do within the class environment.
Okay. Is programming, is there any, are they expected to learn programming explicitly on this module, or?
Yes, so both ways. Either they could go for visual scripting or they could use the normal script programming, the C# programming. So we leave it to the students what they're comfortable with, because some students, if they come from a programming background, they would really complain about using visual tools. And some who are from the arts background would really complain about using scripts. So we give them the choice, whatever they're comfortable with.
Cool, that's good. I was curious about, do you find the students are willing to be creative? Sometimes I find students a little bit reluctant just to get started with that sort of like expressing themselves. Do you find that? Maybe less with the art students.
Yeah. I think that our answer to that is this like small engagement at the beginning that kind of snowballs into the rest of the work behind being creative. So when you say bring an object to class, it's something that's very easily accessible. Someone might have an idea of doing something cheeky like bringing the skull in. It's something that matters to them. And then when you're talked about, okay, well, what do you want to do with this? What do you want to build in? You can't help but kind of lean into that, I think. So I think that encourages the creativity to start happening before you even decided whether or not you were going to engage with it. It kind of, gets you on those railroad tracks to making something that's interesting and unique for yourself.
Yeah, no, that makes sense. actually, another one for you, Xander. I think that collaborative coding lab, you had excellent attendance, and it sounds very interactive. I mean, how did you encourage the students to actually interact and throw things at you?
Yeah, I think it's an interesting one because it was even better attended than the average in-person lab. I think an exact quote I got from a student I ran into last month was people set their alarm clocks for this lab because it was a 9 a.m. one. It's like, yeah, it was a very interesting piece of feedback. But yeah, I think part of it was this fun collaborative experience that even if you weren't the most confident to put something code-wise in, you were still happy to give feedback, respond to questions that I was asking as well. The lecturer, who's the module lead for this one that we kind of slid this into, remarks that there was one particular student they noted was very, very shy in the labs, but were posting the most kind of interactive questions in the online class. So that was very, very interesting. And I think it is that sense of collaboration that even if it was something that you weren't ready to put forward like a suggestion to, you still kind of wanted to be there because, like I said, sometimes it would make mistakes. Those would be entertaining to talk about. It was just an interesting group activity.
That's so cool, yeah. And Verda, I think you said you had no non-submissions. Is that right?
Yeah, to actually literally very minimum to non-submission. And this doesn't happen for my other modules, to be honest. No, it doesn't. And I think just because the students, as I said, like with any of the modules, for instance, talk about rigging, right? You do the rigging process or you do the navigation process. When I am doing the animation, they've scanned, for instance, the bipeds or the quadrupeds that they want to bring in within the game, and they start animating them through either Mixamo or any other resource. You start hearing giggles in the class, and you start seeing things happening even without having to go into Unity. They see their character that they have scanned. It might be their friend, it might be the figurines that they have, for instance, the Spider-Man toy or some other ones, or for instance, Ross. Like, they just started having blast just within by scanning them and bringing that to animation, let alone, the implementation comes later on.
Right. Okay.
Yeah.
Another couple of questions from the chat. Do your students create games or animation for organizations, I guess, for external parties?
So we try and encourage students to take placements. So I think that's where they're exposed to industry. Or for instance, if some of our game students get involved in the live project feed that they have, one of the modules, the industry comes in and they give students projects, and so they kind of have some kind of involvement with the industry, but not but within that remit through their modules.
Yeah, cool. Another one from Ian here. Do you think that bringing your own object breaks the challenge of students feeling the pressure to build things that look like multi-million-pound AAA games? Yeah.
Absolutely. The kind of things, the funny stories I have, I don't think this session is enough for it. One of the students, and the way they get so creative. For instance, like there is a plush bunny that one of the students wanted to scan, right? But because it was so plushy that it wouldn't stick to anything, literally they hanged it from the neck with an invisible thread onto the ceiling so that they could just scan it. So the amount of stories we get is amazing, and the encouragement and the passion that I've seen in students bringing like crazy things to the class, and it's amazing.
Yeah. Oh, that's great. Yeah, it struck me as well that it's breaking down a barrier because you get very
Yeah,
good results for what you're saying is very relatively cheap technology. Is that right?
yeah, absolutely.
Yeah.
Yeah.
And do they use their own phones then? Is that how it works?
So They can if they want to, because most of our students have got smartphones, and these apps can run for some for free as well. But because as a university we've got iPads that has got LiDAR scanners on them, and we've got subscription for Polycam, so they can use the pro versions to get as many scans as they like.
Right. No, that's good. That's good. This is a good question. So, what is the gender mix in these modules, and has that percentage changed over the last few years?
I think within games, I'll talk about RGU, and maybe Xander can shed more light from our day's perspective. I think there's definitely, in terms of games and game design, there we tend to get a good balance of students between, male and female students or binary students. And I think it's definitely better than, for instance, other fields, because it has that element of art and tech expertise mixed together. So yeah.
Yeah, I feel like I would say we're also seeing similar stuff where there is incremental balancing happening. This seems to be happening faster in games programming, which is really, really interesting to me. How that just seems more attractive in general. And for women to get in, and maybe it's more approachable because they do see that design and that gives them the confidence to get in there into the coding. I don't know, but it's also incrementally getting better in the computing and cyber area, but I would say it seems to be at a slower rate.
Okay, that's cool. That sounds very encouraging on both fronts then, both at Abertay and RGU. I think, let's have a look. Yeah, so we've got another question here from the chat. Are the scanning techniques accessible enough that they could be introduced in other game modules where photogrammetry, I was hoping not to say that, is not part of the syllabus, so no time is set aside to teach it to the students? In other words, could they pick this up in a course that wasn't about this, I guess?
I think we could, depending on what the learning outcomes are, right, for the module. So if you were to, for instance, if in one of my 2D Unity modules, they are not the students are not meant to draw things or make 2D arts and whatnot, but they don't have that 3D element. But I think for any of the 3D subjects or 3D game subjects, I would say definitely it takes practice. There are some limitations to photogrammetry, as with any other techniques. If you're especially doing some things outside, doing some photography outside as myself, Scotland is the best place because it's mostly cloudy. And it's not very sunny, so photogrammetry doesn't work well with sunny areas. So Scotland is actually perfect for getting things on board for scanning.
Oh, one of the many advantages of our climate. Yeah, excellent. Okay. Okay. One last question for me then. I think. Oh, Margaret's going. Could you expand on the scholarship? So that the SIXA program, I think.
Yeah. So this is I think it's a yearly opportunity. I know that through SIXA, what we do, SIXA tends to just advertise these scholarships, I think around this kind of time, if I'm not wrong, around September, October time every year. I think Matt can explain a bit more about it. But in a general nutshell, you could apply to being one of the scholars. What that means is, because we tend to be academics, you would think that they work very collaboratively and whatnot, but we don't get much opportunities unless, like, we're put in a situation where there's collaborative work. And we were put into such groups when we met academics from all the different universities in Scotland that had applied, and we kind of worked towards in some of the cool things that we wanted to do through the scholarship. Some of the common issues, for instance, we were facing with students, it might be something to do with marking. For some, it might be something to do with student engagement. It might be something to do with how do we retain students, or there are so many things that we could explore through the scholarship. And one of the things that me and Xander was like, we love games, we love to teach games, games, but what are some of the challenges we face? So maybe Matt can maybe answer that as well.
I've cheated slightly and put a link to the scholars program in the chat because we are bang on time, and so I think that's probably a good place to leave it. Thank you very much, both. Lovely talk, some great talking points as well there. But thank you very much. Over to you, Ian.
Excellent. Thank you very much, and well, thank you, Matthew, for running that. That's great. Thank you, Verda and Xander. And just before I say a proper thank you and end, you said about making mistakes and things should be part of life. I fully agree with that, and I completely forgot to say that this was not just an animation and game specialist group. This was supported by BCS Women Specialist Group, Dorset Branch, e-learning specialist group, and Hampshire branch. So we've got quite a lot of BCS in there. So if we can, in our brains, just take that and do an edit and put it at the start of the webinar, that would be great. But that was fantastic. And I also agree, Matthew, wonderful visuals. And I love the fact that each of your characters appeared when you were talking. And you were hidden often. I mean, you're obviously both there, but you're hidden in each little one. It's like, oh, that's a handy thing when you're doing a two-person presentation to remember who needs to say what, because you're already on the slide. I may have to borrow that. So,
absolutely.
Thank
I was
you very
also
much.
excited that I could get, like, for instance, an inclusive figure for me, and you know, that is representative of my culture. And yeah, it was an easy way for me and Xander to just get on with the slides.
Brilliant. That's fantastic. So thank you very much, both of you, all three of you, in fact, for a wonderful presentation. And yes, thank you all for coming to watch. And there will be a recording of this up on the BCS website for anyone that missed any or arrived a little bit late. So thank you very much.